Hello dear students, welcome back to Chinmoyee's biology channel. So this is the first lesson, that is matter and its surroundings, for the CBSE 9 students. So without further delay, let's get started with today's lesson, matter and its surroundings. So what we are going to learn today, we are going to learn about matter and its surroundings. We are going to learn about the physical nature of matter. We are going to discuss about, we can say that we are going to discuss about matter is made up of small molecules. Particles of matter are continuously moving. Characteristics of particles of matter, that is they are having space in between them, they are attracting each other. So with various examples we are going to discuss today, and we are also going to discuss about the basic introduction about matter and its surroundings. So let's get started, and before starting I will request you to please do subscribe to my channel so that whenever I'm posting the lessons, you will get the update, you will get the notification, and once you are getting the notification, you can continue with the next upcoming lessons which I'll be teaching as per your CBSE curriculum. So stay tuned, stay updated, and let's get started in a very interesting way with today's lesson of matter and its surroundings. So today's lesson is matter in our surroundings. So we all know that whatever we are looking around us in our surroundings, we see large varieties of shapes, sizes and textures. So they all are, we can say that they all are matters. Now everything in this universe is made up of material things. So that material is named as matter. So the air we breathe in, the thing we eat, the stones, the clouds, the stars, the plants and animals, even a small drop of water or a particle of sand is matter. So everything is matter. So we can also look around and see that whatever is matter, it is occupying space and it is having mass. So in other words, we can also say that mass and volume are two important things of matter. Now, since early times, human beings have been trying to understand their surroundings. Now, the Indian philosophers, they told that whatever it is, it should be made up of the Pancha Tattva. So, what is this Pancha Tattva? That is air, earth, fire, sky and water. So according to them, living or non-living, whatever is made, it is made up of these 5 basic elements. Now ancient Greek philosophers has also the similar classification of matter. Now the modern scientists have evolved 2 types of classification of matter based on their physical properties and chemical nature. So in this chapter we will be dealing with the physical properties, and the chemical aspects of matter will be taken up in the coming chapters. Okay, so here we are going to deal with the physical properties of matter. Now first we are going to deal with the physical nature of matter. So we all know that matter is made up of particles. Okay, so for a long period of time, like 2 schools of thought prevail, like nature of matter. One school, they believed that matter is continuous like a block of wood, whereas the other thought that matter was made up of particles. So some used to think that it is like a block of wood, whereas other told that it is made up of particles like sand. So there are 2 schools of thought which believe matter in 2 different ways. So let us perform an activity to decide whether the nature of matter is continuous or particulate. Okay, so this is very important. Whether it is particulate or it is continuous, we should know that. So let us do the experiment. Now take a 100 ml beaker, fill the beaker with water and mark the level of water. Now dissolve some salt or sugar with the help of a glass rod. Observe any change in the water level, and what do you think? What happened to the salt? Where does it disappear? And why does the level of water change? So in order to answer these questions, you need the idea that water, whatever is mixing in water, they are particles. They are not, we can say that they are particles, they are in particulate forms. So what was there in the spoon, salt or sugar, now has spread throughout water. So we can say that particles of matter, of water magnified millions of times. Now it has been added, salt has been added, it has been stirred, and we can see that water and salt. So when we are dissolving water in salt, the particles they get into the spaces between the particles of water, so they are getting dissolved in water. So these are very small particles of matter. So how small these particles are, that we should also know. That again we should perform an experiment to know that how small these particles are. So we are taking only 2 to 3 crystals of potassium permanganate and dissolving them in 100 ml of water. Okay, now we are taking, so you are seeing that this is 100 ml of water. We are dissolving 2 or 3 particles of potassium permanganate and dissolving in it 100 ml of water. We are taking out 10 ml of water from that beaker and again diluting 10 ml of clear solution to that to make this again 100. Again taking out 10 ml, making putting clear solution 10 ml and making it 100. Again the same thing continues. So what we can see at last is the water color, is it same? No. So we can estimate how small is these particles are. So this experiment is showing just a few crystals of potassium permanganate can color a large volume of water, about 1000 liter. So we can conclude that there must be millions of tiny particles in one crystal of potassium permanganate, which will keep it dividing into smaller and smaller particles. So what happened? Only the color has faded, but the color has not gone away. So the particles are very, very, very small. So the same activity can be done using 2 milliliter of Dettol instead of potassium permanganate. So you can see that the smell can be detected even after repeated dilution. So same experiment, we can observe the smell after repeated dilution also. So these particles of matter are very small. We can say that they are very small and they are beyond our imagination. Is it clear? So in the next slide, we will be dealing with characteristics of the particles of matter. So now we are going to deal with characteristics of the particles of matter. So the particles of matter, they have space in between them. We all know that they are having space in between them. The particles of matter, if they are not having space in between them, then we could not dissolve the potassium permanganate in that water solution, or Dettol would not have dissolved in water, or sugar and salt solution. Okay, so the particles of they are having space in between them. Is it clear? So in activities of sugar and salt, we have already Dettol, potassium permanganate, we have already seen that the particles are evenly distributed in water. Similarly, when we make tea, when we make coffee, lemonade or lembu pani, particles of one type of matter get into the spaces between the particles of another, and this shows that there is enough space in between the particles of matter. So enough space is there in between the particles of matter, and we will do another activity to see that the particles of matter are continuously, they are moving. They are not at all static, they are not at all stagnant, they are continuously moving. So the first activity is, if you put an incense stick in the corner of your class, how close do you have to go near it to smell it? Do we go near it to smell it every time? No. First, if you are not lighting the incense stick, then you will have to go near it and smell it. As soon as you light the incense stick, then what is happening? Then you can smell the incense stick's aroma throughout the class. So the aroma has mixed in between the gas particles, which is being continuously moving in the classroom. So we get the smell of the incense stick. Now another activity is there. In this activity, what we can all do is, we can take two glasses and beakers filled with water. Now put a drop of blue or red ink slowly and carefully along the sides of the first beaker, and honey in the same way in the second beaker. So leave them undisturbed in your house or in the corner of the class for some time. And what are the observations? What do you observe immediately after adding ink drop, and what do you observe immediately after adding a drop of honey? So how many hours or days does it take for the color of the ink to spread evenly throughout the water? So you can just make it out that you know that honey is thicker than ink. So as you drop ink from the side of this beaker, it will mix quickly than the honey, because of its state it is much thicker than that of ink. So these are the observations you need to observe when you are doing this experiments in class as well as home. These are very easy observations. The ink will mix very quickly, whereas the honey will take a little bit more time to mix, though it is a liquid only, but it is not as smooth as ink. So it is a bit thicker type of liquid. Okay, now next let us move on to the next activity. Now drop a crystal of copper sulfate or potassium permanganate into a glass of hot water and another containing cold water. So what will happen in hot water and cold water? You need to see the difference. Now allow the crystals to settle at the bottom. What do you observe about the solid crystals in the glass, and what happens as the time passes? What does this suggest about the particles of solid and liquid? Does the rate of mixing change with the temperature? Why and how? So from the above three activities and what we can conclude, we will come up to that now. Now, particles of matter are continuously moving, that is, they possess what we call the kinetic energy, and when the temperature increases, the particles start moving faster, because the increase in temperature, the kinetic energy of the particle also increases. In the above three activities, we observe that the particles of matter intermix on their own with each other. So they do so by getting into the spaces of the other particles, like mixing of the aroma of incense sticks in air, mixing of ink or honey in that liquid or water. So these types of two different, when they are intermixing, is called the diffusion. So this process is called diffusion. We also observe that heating makes diffusion faster. So as you heat the substance, the diffusion becomes faster. Is it clear? Now in the next slide, we will be discussing that particles of matter attract each other. Now we will be starting with particles of matter attract each other. So here they have already started with one experiment, or we can say that it's an activity. So what is the activity? Now we can say that this is a play this game in the field and make 4 groups and form human chains as suggested. So human chains means all human beings should be there on the field. So you can make your friends and you all can make groups. So there should be 4 groups. The first group should hold each other from the back, as shown here. They should hold each other from the back and lock arms like the Idu Mishmi dancers. So like them, they should lock arms and hold each other from the back. The second group should hold hands and form a human chain. The third group should form a chain by touching each other at the fingertips only. So the now fourth group of students should run around and try to break 3 human chains. So these small, suppose you have made 4 groups of 5 each. So first one, they are holding each other from their back. Second group, they are holding their hands in the form of human chain. And the third one, they are touching each other with the only fingertip. And the fourth group is running around and trying to break 3 human chains. So which group will be the easiest to break? You all know that the third group, which is touching each other with their fingertips, will be easier to break, and this group will be the toughest to break. So like this only, we can say that if we consider each student as a particle of matter, then in which group the particles held each other will have the maximum force. So you can say in the first group, they'll have the maximum force when the particles are holding each other tightly, and the third group, where the particles are holding each other loosely, they'll have the least force. Now next activity, take an iron nail and take a piece of chalk and a rubber band. So try breaking them by hammering, cutting or stretching. Okay. So in which of the above 3 substances do you think the particles are held together with greatest force? So you have taken iron nail, chalk and rubber band. So the iron nail is the toughest one, where the particles are held together with a greater force. Is it clear? So let's move on to the third activity. Take some water in a container. Try cutting the surface of water with your fingers. Now you can do it at home, if you are taking a bucket or a pot of water, try to cut the surface of water with your fingers. So were you able to cut the surface of water? Is it possible? No, it's never possible. What could be the reason behind the surface of water remaining together? So the above three activities suggest that particles of matter have the force acting in between them. So the force keeps the particles together, and the strength of force of attraction varies from one kind of matter to another. So in the previous classes, you have also known that this force of matter is highest in solids, then after that in liquid, and then least in the gases. And now we can see that several questions are there. So please try to answer these questions. If you are not getting these questions, write in my comment box. I'll answer you in the next class. So what are the questions? Which of the following are matter, chair, air, love, smell, hate, almonds, thought, cold, lemon, water, smell of perfume? So what are matter? Give reasons for the following observation, that the smell of hot sizzling food reaches you several meters away, but to get the smell from the cold food you have to go close. Why? So just now we have taught that. Please try to answer the questions with logical reasoning, so that you get good marks in the that reasoning part. Give reasons, right? So if you are not getting the answers, please ask me the questions in the next comment box, so that I'll tell you the answers. A diver is able to cut through the water in a swimming pool. Which property of matter does this observation show? And what are the correct characteristics of the particles of matter? So let us move on to the next slide. So in the next video or the next class, we will be discussing in details about the states of matter. In the previous classes also, you know, the solid state, the liquid state, and the gaseous state are the three states of matter. But with different activities, we should know all the different states in a bit we can say in a bit expanded version from the previous classes what you have learned. So please subscribe to my channel, stay tuned, stay updated with all the upcoming lessons which I am going to teach you as per your curriculum. So if you are having any queries, any doubts, please do write in the comment box, and stay tuned and share it with your friends. Thank you.